So this is the part whole mat, and I usually use this in a sheet protector or laminated. That way students can write on it and erase it and reuse it over and over again. However, as the students get older, they can start drawing this on their own. As the problems get more complex, it's really important for students to identify what's the part, what's the whole, what's missing, because that can help them identify what the process is to solve the problem. Here's another way to look at it. They're a lot smaller. This is a worksheet. So I'm just going to explain how this works. So they gave us the whole, and if you can see here, they numbered it for us. So let's count 1, 2, 3, 4, 5, 6, 7. Now this has no context. There is no word problem here. My job is just to split them up in 2 parts. That's all it says. So I can choose however many I want. I'm splitting up these 7 blocks into 2 parts. So I'm going to pick 1, 2, 3. And I can either just write the number 3, or I can draw the 3 blocks. Now, what students might do is see this and write 7. That's not the answer. They see the end number here and they think 7. But 3 plus 7 does not equal 7. We've gotten rid of 3, and now we need to see how many more we have in order to make 7. So 1, 2, 3, 4. That's why coloring it in is so important, because the students can then eliminate and see which block, how many blocks they have left. So the addition problem for this would be 3 plus 4 equals 7. We could also do a subtraction problem of 7 minus 4 equals 3. Now, this is called decomposing, breaking apart this whole into 2 different parts. What we want students to do is to be able to break up this whole of 7 or 5 or 3 or 10 into as many different combinations as they can. So I could have done 2 and 5. I could have done 1 red and 6 gray. There are many different options, but we want students to be able to see that and recognize that. Let's try another one. The whole. Let's see how many are in the whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now it's my choice how I want to break it up into 2 parts. I could do 1 red and then 9 gray. I could do 2 red and then 1, 2, 3, 4, 5, 6, 7, 8 gray. I could do 3 red and the rest gray. That would be 7, 3 and 7. I could do 4, and that's what I'm going to do. I'm going to do 4. Red, and then 1, 2, 3, 4, 5, 6. And so my addition problem for this would be 4 plus 6 equals 10. I could do 6 plus 4 equals 10. Those are my 2 parts. I just switched them. And then I could do 2 subtraction problems too. 10 minus 4 equals 6. I had 10. I took away 4. I have 6 left. Or 10 minus 6. I have 10. I take away 6. I have 4 left.